Hello, my name is Ryan Barnes, and this will be a short video detailing the final project for Introduction to R from Dr. Wayne Stewart at the University of Oklahoma. So this project is basically two different functions. First, the myBoot function for bootstrapping, and then the mySLR for simple linear regression. We'll need two different packages for these functions. The first one is going to be ggplot2 for plotting, and the S20X package for confidence intervals and other simple statistics. And then we're going to look at the MT cars data set for this project, so specifically miles per gallon and weight of the cars. So we'll load that in as well. And we'll get right to it with the first function, which in this case is the myBoot function. So this function creates confidence intervals for a specified stat, or stats in this case. You could pass it the mean as well here, or something similar. Anything that will work with the apply function here, because here's our argument stat. So this will plot a histogram of the Bootstrap distribution. And then it will also write a CSV containing the samples. You can see that we just need to pass it a numeric vector x, and then our confidence interval based on alpha there. Here it defaults to the 95% confidence interval. Iterations defaults to 10,000, and then you can also pass it whatever title you'd like. It defaults to the density of the statistic that you've passed in. The next function is the mySLR function. This function creates a simple linear regression from x, our dependent or independent variable, and y, our dependent variable, for the response. And it plots the regression line. It will save the regression, the model for you as well. The confidence interval, it will save an output. It'll also save the plot here. It will make a new prediction based on the original sample x plus some noise here, and we're going to square that because we want to keep a positive weight. Our variable is going to be weight. We don't want a negative weight. It makes that prediction, and then it writes that prediction with the new x values and the corresponding miles per gallon associated with that weight. Outputs the summary of the regression, and then it saves these objects so that you can access them later. Alright, so let's quickly demonstrate the mySLR function by passing the weight and the miles per gallon as our y. And there's our plot, and here's our output. So you can see the confidence intervals for beta naught here, or the intercept, and beta 1 here, which is the slope of the line. And then we also can look at the quantiles of our residuals here. And you can see that both the intercept and the slope are statistically significantly different from 0. This is what these values tell us here. And then our r-squared values here, so a decent fit. And if we go back to the files, you can see that this plot has been saved, and we can open it up to see that. And also our prediction, we can see the new x values in the first column, and then the y values associated with those weights. Okay, so now we'll demonstrate the Bootstrap function, myBoot. And we're going to pass it only those cars with 4-cycle engines. And we're going to use the miles per gallon again and pass it this title as well. So this will output our distribution density plot over here as well. And you can see our confidence interval here with the point estimate 18.38. So that looks about right on the plot there. And also it is saved. Now this Bootstrap file CSV file of all the samples, the calculated variance of those samples for 10,000 iterations.